In this video, you will learn to determine if two ratios are equivalent, as well as how to solve for an unknown part of a proportion. So first off, we must understand what is a proportion. So a proportion is simply two ratios that are equivalent or equal. So for example, we have 5 over 10 equaling 1 over 2. That would be a proportion because we have one ratio right here, 5 over 10. Our second ratio is 1 over 2, and these are equal or equivalent. They are the same value. So we would say that 5/10 and 1/2 are proportional because they are equivalent. And the word equivalent just kind of means equal, all right, same value. So how do we test for equivalency? How do we determine if two ratios are indeed equal? Well, one way is we can simplify to lowest terms. So if we have 9 over 12 and 21 over 28, and we're trying to determine are they equal? Well, I can reduce or simplify both of these fractions and determine from those simplified numbers. So 9/12, we can divide top and bottom both by 3 to get 3 over 4. 21 and 28, we can divide top and bottom by 7. 21 divided by 7 is 3. 28 divided by 7 is 4. So we've simplified as far as we can. We have 3/4 and 3/4 for both fractions. And that's true, like they're equal to each other. So therefore the two fractions will be equal as well. And by the way, these 3 dots right there, that means therefore. So that's math notation. You'll see from time to time that means therefore. All right, so because when you simplify, we get 3/4 and 3/4 because those are equal. Therefore, we can conclude that 9/12 and 21 over 28 are equal as well. Now, another method for testing if two ratios are equivalent is by division. So here we have 5/6 and 8 over 10. When we say division, what we mean is we can take this fraction and divide. So we divide 5 by 6 because, again, fractions mean division. So we could do 5 divided by 6. And we're not going to go through that process necessarily. We're going to assume you know how to do that. But if you do it correctly, you're going to get 0.83 repeating. Okay, that one is probably a fraction you should have memorized as well. But if you don't have it memorized, you can go through the process and we get 0.83 repeating. And then 8/10, we can do the same thing, 8 divided by 10. And this one you should have memorized to be 0.8. If you don't have that memorized, you'd have to add a decimal and a 0. 10 goes in 88 times. 8 times 10 is 80, subtract, no remainder. So 8/10 would be 0.8. All right, so notice 0.83 repeating is not equal to 0.8. They're not the same number. So therefore, the two fractions are not equal to each other. So again, we see that symbol, therefore, the 3 dots, and then this symbol with an equal sign and a line through it, that means not equal. So we can write it like that, not equal. So that's 2 different methods. We could simplify, we can divide, and a third method is we can cross multiply. So for example, if we had 4/12 and 1/3, and we're trying to determine if they are equivalent. I think a lot of you would just tell right at the beginning that, yeah, 4/12 could reduce or simplify to be 1/3. But this method of cross multiplying could also work, where notice the color coordination. If you multiply across, so like the 4 and the 3, multiply across like that, 4 times 3, and then multiply across the 12 times 1. If you do that, 4 times 3 on the left, 12 times 1 on the right, we have 12 equaling 12. So because that is a true statement, because they are equal, we can conclude that therefore the fractions must be equal as well. So cross multiplying is a third technique that we can use. And there's other ways we can test for equivalency. You could just use your number sense to realize that two fractions are equal. So there's different methods you could use, but here are just three that we have at our disposal. So this process of cross-multiplying is not only used to determine if two ratios are equivalent, but we can also use this to solve. So this relationship where you multiply across and multiply across over here, that will always be true with a proportion. Okay? If you have a true statement, something equaling something, and it is indeed equal, so if you know that to be true for sure, then this will always be the case, where you can multiply across, and when you multiply across, that would be equal as well. So for example, if we had 4 over 5 equals 12 over x, and our objective is to solve for x. So again, we don't always have to cross multiply. We could use number sense, our understanding of fractions, to realize that 4 times 3 on the top gives you 12. So same thing in the bottom, 5 times 3 would give you 15. So you could use that method, but here we're trying to show you this process of cross multiplying, because you're going to use this process for more difficult questions, and as you progress into your study of algebra, you're going to add more complication to the problems. So you do want to know this method, even though that you might be able to use another method instead. You want to be familiar with this method also. So using the cross multiplication method, what we would do is we would take 4 times this unknown value of x, so 4 times x, and set that equal to, and then we multiply across 12 times 5. So if you do that, we'd have 4 times x, or 4x, equaling 60. And then to solve for x, we would get rid of this 4 that's being multiplied. We do that by dividing both sides by 4. So now we have x on the left, and 60 divided by 4 is 15 on the right. So our solution using the cross multiplication method would be the same, would be 15, as it would for using the other method that we showed right before that. So notice this does give us the correct answer. Let's take a look at another example. Here we have 7 over 11 equaling x over 5. So notice this problem, you could not just get from 11 to 5. We cannot just divide the top and the bottom by the same number. So this one is going to require us to use cross multiplying. So to cross multiply, we would do 11 times x. You multiply across like that. So 11 times x equals, then multiply across 7 times 5. So we have 11 times x equaling 7 times 5. So 11 times x is the same thing as 11x, and then 7 times 5 is 35. And then to solve for x, we just get rid of the 11. The 11 is being multiplied. So to get rid of it, we must do the opposite of multiplying, which is divide. So we divide both sides by 11. Now we have x equaling 35 divided by 11, and it's best to either write this as a mixed number or as a decimal. So if we do 35 divided by 11, okay, 11 goes into 35 3 times. 3 times 11 is 33. Subtract, and we get 2. So 2 is our remainder. We can write that as a fraction if we want, as 2 over 11. So that would be 3 and 2 11ths. You can leave it like that, or you can write it as a decimal. If you continue the process of dividing, we would find that we'd get 3.18 if you round to the nearest hundredth. So just follow the directions. If it says write as a fraction, keep the fraction. If it says write as a decimal and round, you can use the decimal. Now, cross multiplying, like we said, is used to solve different equations, but we can also use this to solve word problems. So in real life, you can actually use this. And in my real life, I have indeed actually used this for different things. So the example here we have is 2 cups of coffee cost $5. And the question is, how much would 4 cups cost? So we're starting with a pretty basic one you could probably do in your head to show you how this works. And the next example is going to be a little more difficult. So what we do is we want to use the information given to create a proportion. So right here, 2 cups of coffee costs $5. we can write that as a fraction. We can compare the cups of coffee, so 2 cups, compare that with the price of $5. That's the cost. So if that ratio is going to remain true, we can use that to set equal to this other information. So how much would 4 cups cost? So 4 cups, that would go on the top of this other fraction because the cups were on the top over here on the left side. Put the cups on the top on the right side. And then on the bottom should be costs, and that's what we're trying to find, right? How much would 4 cups cost? That's your unknown. That's going to be your variable. So we don't need the units written, but it might be helpful to at least think of them as being there, so you can make sure we have cups and cups both on the top, costs and costs both on the bottom. So just looking at the numbers, we'd have 2 over 5 equaling 4 over x. So this is our proportion. So if we're getting practice with the cross-multiplying method, we would have to do 2 times x for that part, and then that's equal to 4 times 5 over here. Well, 2 times x is 2x, that's equal to 20. 4 times 5 is 20. And then to solve for x, we get rid of the 2. The 2 is being multiplied, so to get rid of it, we can divide both sides by 2. That gives you x equaling 20 over 2, which would be 10. So our answer is x equals 10. And always look back at the original problem to figure out the context, figure out what is 10, like what units would that be. Well, that's how much it costs, right? How much would 4 cups cost? That is the cost of 4 cups. So the 10 we can write as $10. That is the cost of 4 cups of coffee. Let's take a look at one more example. And this one, we are told that we have a homemade pancake recipe. And by the way, this is an actual recipe that I personally have used and I really enjoy. And the recipe calls for 4 eggs, 1 cup of oatmeal, and 1 banana. Okay, and then what you do in real life is you blend it together and then cook it on a griddle or on a pan. But anyway, so that's the recipe. And if you want to use 10 eggs, the question is how much oatmeal is needed. All right, so we're looking here at eggs and oatmeal. That is what we're trying to figure out. So we're looking at eggs and oatmeal. So the banana is actually not necessary to answer this question. That's just part of the recipe. But to answer the question, we're looking at eggs and oatmeal. So we're looking here, 4 eggs for 1 cup of oatmeal. So that the relationship, the ratio, is 4 eggs over 1 cup of oatmeal. All right, so that's the ratio. So if you want to keep it proportional, you want to keep the same ratio, you would have to use or set it equal to this other part where now we have 10 eggs. So eggs were on the top over here for the first fraction. Put eggs over on the top for the second fraction. All right, and then on the bottom, we're trying to figure out how much oatmeal is needed. So oatmeal's on the bottom, oatmeal's on the bottom over here. So this is my proportion. And to solve this, we don't need to have the units, we just look at the numbers. So we have 4 over 1 equals 10 over x. All right, so to solve this using cross multiplication, we would do the 4 times x equals, and then we do 10 times 1. So we have 4 times x equals 10 times 1. Now, 4 times x is just 4x. 10 times 1 is 10. So now to solve for x, we can get rid of the 4. The 4 is being multiplied, so to get rid of it, we must divide. We divide both sides by 4. So we have x equaling 10 divided by 4. Well, what is 10 divided by 4? Well, 4 goes into 10 2 times. 2 times 4 is 8. Subtract, we get 2. So the remainder is 2. We can write that as a fraction, 2 over the 4. So we have 2 and 2/4, which can reduce to be 2 and 1/2. So the answer is 2 and 1/2, and we were talking about cups of oatmeal. So the answer is it would require, if you're using 10 eggs, you would want 2.5, That should be cups of oatmeal. So that is your solution. And by the way, this recipe is really good if you put some cinnamon, mix that in. You could even do a little brown sugar. And I've used chocolate chips as well. So it's an actual recipe. Maybe give it a shot, see if you like it. And this is a real life problem where I, in real life, have had to increase the batch because I was making some pancakes for my siblings or whatever, and we only had maybe a certain number of eggs to work with. So this is real life. You can use math, you can use proportions, ratios, cross multiplication, all of that to figure out real life scenarios. And that concludes our lesson for today. We will see you next time.